We all know that digital computers changed virtually every aspect of our life. Well, the arrival of quantum computers could be even more historic than that. We're now at the initial stages of the next revolution.
Scientists have built machines that literally borrow computational power from parallel universes. These quantum computers don't just process information faster, they process information that exists in multiple realities simultaneously. But something unprecedented happened that has shaken the scientific community to its core. NASA recently shut down its quantum computer after it produced results that contradicted known physical laws. During routine testing designed to simulate complex space systems, the quantum computer generated calculations that defied our current understanding of physics.
Understood that building a useful quantum computer was going to be a staggeringly hard engineering problem, if it was even possible at all.
NASA scientists are still investigating what went wrong, but the implications are staggering. Dr. Michio Kaku, the renowned theoretical physicist who co-founded string field theory, warns that we've crossed a line we can never uncross. These quantum machines are going to rewrite the fundamental rules of what it means to be human. The NASA incident highlights a critical reality. Quantum computers are producing results we don't fully understand. As machines begin to compute across multiple realities, what happens when they uncover truths that challenge our established understanding of the physical universe? Some researchers suggest that quantum computers have reached insights beyond the limits of our existing scientific frameworks. These machines are about to crack every password on Earth in seconds, design miracle drugs by simulating reality at the atomic level, and potentially help us achieve digital immortality by uploading our consciousness into quantum systems. But the NASA shutdown reveals that they might also be accessing information from dimensions we can't even perceive. The race isn't just to build them anymore, it's to control them before they control us. According to Kaku, quantum computing is advancing faster than our ability to understand its consequences. We're building machines that could solve any problem, cure any disease, or break any security system, but we're also creating tools that might fundamentally challenge our understanding of reality itself.
That's kind of a crazy sounding idea, but a quantum computer perhaps can harness that by doing some calculations over here and other calculations over there in parallel. Now it's doing, in some sense, twice as many calculations as a classical computer existing in one world would be able to do.
In the next 15 minutes, I'll show you exactly how quantum computing is about to transform our understanding of reality, why NASA's unexpected shutdown matters, and why Michio Kaku believes this technology will determine whether humanity transcends its current limitations or faces unprecedented risks. To grasp the revolutionary nature of quantum computers, we must first understand how they differ from classical computers. Traditional computers process information using bits, binary units that exist in one of two states, either 0 or 1. Every calculation, every program, every digital process relies on manipulating these binary states at incredible speeds. Quantum computers operate on entirely different principles. They use quantum bits, or qubits, which can exist in a state called superposition, simultaneously being 0, 1, or both at the same time. By leveraging this advantage, quantum computers can process enormous amounts of information almost instantly, and classical computers simply can't compete with it. Michio Kaku explains this phenomenon by comparing it to exploring a maze. While a classical computer would test each path sequentially, a quantum computer explores all possible paths simultaneously across multiple probability states. Their ability to operate in parallel states is what gives quantum machines their remarkable processing power. The concept extends beyond simple calculation speed. Quantum computers harness quantum entanglement, where particles become interconnected in ways that changing one instantly affects the other, regardless of distance. Einstein famously called this spooky action at a distance, but modern quantum physicists have learned to harness this phenomenon for computational purposes. The recent NASA quantum computer shutdown provides a sobering example of how little we truly understand about these machines. NASA's quantum computer was designed to simulate complex systems found in space exploration, modeling everything from spacecraft trajectories to the behavior of materials under extreme conditions. During what should have been routine testing, the quantum computer began producing results that directly contradicted established physical laws. The calculations were mathematically consistent within the quantum framework, but they suggested possibilities that our current understanding of physics cannot accommodate. NASA scientists immediately shut down the system and launched a comprehensive investigation. The incident raises fundamental questions about the nature of quantum computation and its relationship to physical reality. When quantum computers process information across multiple probability states, they might be accessing aspects of reality that classical physics hasn't yet discovered. Some researchers speculate that the quantum computer was processing information from parallel computational realities, essentially downloading knowledge from alternate versions of physical laws. This possibility, while scientifically intriguing, also presents significant challenges for how we develop and deploy quantum technologies. The NASA incident demonstrates that quantum computers don't just calculate faster, they calculate differently, potentially accessing information that exists beyond our current scientific paradigms. Dr. Michio Kaku has spent decades studying the implications of quantum mechanics for human civilization. As co-founder of string field theory and author of numerous books on theoretical physics, Kaku brings unique insights to quantum computing's potential impact. Kaku describes quantum computers as the ultimate computers because they operate at the most fundamental level of reality, manipulating individual atoms and subatomic particles. He argues that any advanced civilization in the universe would inevitably develop quantum computing technology, making it a crucial milestone in technological evolution. According to Kaku's analysis, quantum computers represent more than just faster processing power. They offer access to computational capabilities that mirror the quantum mechanical processes underlying all physical reality. This alignment between computing technology and natural law creates unprecedented opportunities for scientific discovery and technological advancement. The NASA incident aligns with Kaku's warnings about quantum computing development, accelerating beyond our current ability to fully comprehend its implications. He emphasizes that we're entering an era where the technology's capabilities may outpace our wisdom in applying it responsibly. Kaku has long predicted that quantum computers might reveal aspects of reality that challenge our fundamental assumptions about the universe. The NASA shutdown suggests this prediction may be coming true sooner than expected. The practical applications of quantum computing span multiple fields, each with transformative potential for human civilization. Quantum computing presents both transformative possibilities and serious risks to global security infrastructures. Current encryption methods rely on mathematical problems that would take classical computers thousands of years to solve. Quantum computers can solve these same problems in hours or minutes using algorithms like Shor's algorithm. This capability means that virtually all current digital security systems, from banking networks to military communications, could become obsolete overnight. At the same time, it opens the door to quantum cryptography, communication secured by the very laws of quantum physics, theoretically immune to being cracked. Kaku believes quantum computing will revolutionize medicine by enabling precise molecular simulations. Classical computers struggled to model complex molecular interactions because they involve quantum mechanical processes. Quantum computers can simulate these interactions naturally, potentially leading to breakthrough treatments for diseases like Alzheimer's, Parkinson's, and various forms of cancer. The technology could enable personalized medicine tailored to individual genetic profiles, with treatments designed at the molecular level for maximum effectiveness and minimal side effects. Quantum simulations might also help us understand aging processes at the cellular level, potentially leading to life extension technologies. Climate change involves incredibly complex systems with countless variables interacting across multiple scales. Quantum computers could model these systems with unprecedented accuracy, potentially identifying solutions that classical computers cannot discover. These simulations could optimize renewable energy systems, design more efficient carbon capture technologies, and predict environmental changes with greater precision. The ability to model complex chemical reactions could also lead to new materials and processes for environmental remediation. The combination of quantum computing and artificial intelligence represents one of the most significant technological convergences in human history. Quantum-powered AI systems could process information in ways that transcend current machine learning limitations. These systems might develop quantum intuition, making logical leaps that seem impossible because they process information from parallel computational realities. Quantum AI could simultaneously analyze every possible outcome of complex scenarios, leading to decision-making capabilities far beyond human comprehension. The NASA incident raises important questions about quantum AI development. If quantum computers can access information that contradicts known physical laws, what happens when we combine this capability with artificial intelligence systems that can learn and adapt? One of Kaku's most fascinating predictions involves the potential for digital consciousness transfer. He envisions a future where human consciousness could be uploaded into quantum systems, achieving a form of digital immortality. This process wouldn't simply copy memories or personality traits. Instead, it would transfer the actual quantum processes that generate consciousness into quantum computing systems. The result would be a form of existence that transcends biological limitations while maintaining individual identity and awareness. Quantum consciousness transfer could enable experiences impossible in biological form. Thinking across multiple realities simultaneously, accessing information from quantum probability states, and existing in multiple locations at once. This technology could fundamentally redefine what it means to be human. However, the NASA quantum computer incident adds a new dimension to these possibilities. If quantum systems can access information beyond our current understanding of physical reality, digital consciousness might experience aspects of existence that biological consciousness cannot perceive. The race for quantum supremacy has become a matter of national security for major world powers. The United States has invested billions through initiatives like the National Quantum Initiative Act. China has committed even larger resources, building massive quantum research facilities and launching quantum communication satellites. Europe has established the Quantum Flagship Program, investing over 1 billion euros in quantum technology development. Private companies like IBM, Google, and Microsoft are making significant advances, while startups worldwide are pushing the boundaries of quantum applications. The NASA incident has intensified international interest in quantum computing research. The possibility that quantum computers might access information beyond current scientific understanding has significant strategic implications. Nations are now racing not just to build quantum computers, but to understand and control their unexpected capabilities. The nation or organization that achieves practical quantum advantage first could gain unprecedented strategic advantages. Quantum computers could break enemy encryption while protecting their own communications, optimize military logistics in real time, and develop advanced materials for defense applications. Kaku acknowledges significant risks associated with quantum computing development. The technology's power to break existing security systems could destabilize global financial markets and compromise national security systems worldwide. The NASA incident highlights additional risks that weren't previously considered. If quantum computers can produce results that contradict known physical laws, they might also generate information that challenges our fundamental understanding of reality. This capability could lead to discoveries that humanity isn't prepared to handle. The emergence of AI driven by quantum technology raises urgent concerns about control, oversight, and ethical alignment. If these systems evolve beyond human understanding and can access information from parallel realities, ensuring they remain beneficial to humanity becomes increasingly difficult. There are also fundamental questions about the nature of reality itself. Some researchers suggest that quantum computing experiments might reveal that our universe exists within a larger cosmic structure, potentially a black hole in a parent universe. The NASA incident provides evidence that quantum computers might already be accessing information from these larger structures. Current quantum computing development is progressing rapidly, despite setbacks like the NASA incident. IBM's quantum processors have exceeded 400 qubits, while Google's Willow chip has demonstrated significant advances in quantum error correction, a crucial step toward practical quantum computing. Kaku predicts that within 5 years, quantum computers will become competitive with classical computers for specific applications. Within a decade, they may be capable of addressing almost any computational problem. However, the NASA incident suggests that the most transformative applications may emerge sooner than expected, potentially in ways we don't anticipate. Quantum sensors are already being developed for medical imaging and scientific research. Quantum communication networks are being tested for secure government and financial communications. The challenge now is developing quantum computers that can harness their extraordinary capabilities while maintaining control over their unexpected behaviors. The quantum revolution represents more than technological advancement. It marks a fundamental shift in humanity's relationship with information, reality, and consciousness itself. Quantum computers could help us understand the deepest mysteries of physics, from the nature of black holes to the possibility of multiple universes. The NASA incident suggests that quantum computers might already be providing glimpses into these deeper mysteries, even when we're not prepared to understand them. This capability could accelerate scientific discovery in unprecedented ways, but it also requires new approaches to managing and interpreting quantum computational results. These technologies might enable us to transcend current biological limitations, extending human lifespan indefinitely and expanding our cognitive capabilities beyond current imagination. The ability to simulate complex systems could help us solve problems that have plagued humanity for millennia. However, the same technologies that offer unprecedented opportunities also present existential risks. The concentration of quantum computing power in the hands of a few nations or organizations could create new forms of inequality and control. The NASA incident demonstrates that quantum computers might also challenge our fundamental understanding of reality in ways we're not prepared to handle. Michio Kaku's vision of our quantum future reveals both extraordinary opportunities and significant challenges. The recent NASA quantum computer shutdown adds urgency to these considerations, demonstrating that quantum computers are already producing results that challenge our understanding of physical reality. Quantum computers represent the next fundamental leap in human technological capability, offering solutions to problems we currently consider unsolvable. The technology promises breakthroughs in medicine, climate science, artificial intelligence, and our understanding of reality itself. The possibility of digital consciousness transfer could redefine human existence, while quantum simulations might unlock the secrets of the universe. However, the NASA incident reveals that this power comes with unexpected complexities. When quantum computers can access information that contradicts known physical laws, we must develop new frameworks for understanding and controlling their capabilities. The decisions we make about quantum computing development and deployment will determine whether this technology becomes humanity's greatest achievement or its greatest risk. The NASA shutdown serves as a reminder that we're dealing with forces that operate beyond our current scientific paradigms. The quantum revolution is not a distant possibility. It is happening now in laboratories around the world. The question is not whether quantum computing will transform human civilization, but whether we will be prepared for the transformation when it arrives, especially when that transformation might challenge our fundamental understanding of reality itself. The future of humanity may well depend on how wisely we navigate the quantum age that is already beginning to unfold, and how we respond to the unexpected discoveries that quantum computers are already making. So if you're the kind of person who wants to witness the birth of quantum civilization, follow Space Aquarius and smash that like and subscribe button, and don't blink. You might miss the moment when quantum computing changes everything forever.